So, you've often heard of the term LLM as a judge. Let's put that somewhere here. LLM as a judge. Yeah, this is where an LLM produces an output, then you use another supervisor LLM to actually check the work of the first LLM to see if it is up to a particular standard or meets a certain criteria. That's what LLM as a judge is all about. One LLM is doing the work, another LLM is supervising and making recommendations until a satisfactory criteria is met. The Evaluator-Optimizer workflow helps you to set up this type of system. So imagine that you want to generate a report. So you generate a report and you use an LLM. You use an LLM to generate a particular report. Now you then have another node in your graph that has been given a set of instructions, criteria, like a checklist, to check the work of this first guy. So this first guy generates his output and sends it to this guy. This first guy is called the generator/optimizer. Optimizer. Good. So this first guy is called the generator/optimizer. And this guy is called the evaluator. So the generator generates a first draft, sends it to the evaluator. The evaluator then checks this draft against its list of criteria or checklist of standards to be met, scores the work, checks if the score is above a certain threshold. That's one of the main metrics that you can use to determine whether it is good enough. If it is not at that threshold or above that threshold, it will be sent back. It will be sent back. Now, it won't just be sent back. It will be sent back with a list of recommendations. Yeah, correct this, fix this, clean this up, remove this. To send it back, then the optimizer is going to optimize. So this node performs two functions. When it is producing the first draft, it is serving as a generator. Then when it is correcting its draft based on the recommendations from the evaluator, it is serving as an optimizer. So it generates a draft, sends it to the evaluator checks it, sees if it is good enough. If it's not good enough, it sends it back. If it's not good enough, it sends it back. This guy will fix again, send it, he will check, send it back. And if it is actually producing the right instructions on how to correct the document, it shouldn't take too many iterations for this guy to generate a satisfactory draft. The evaluator will see it and approve it, and then your workflow can continue. Your workflow can continue with the next steps. So yeah, that is how this pattern works. It's an iterative workflow where one LLM call generates the content, that is the generator or optimizer, and another LLM evaluates the content, that is the evaluator. If the evaluator determines that the content doesn't meet the success criteria, feedback is going to be provided and sent to the optimizer to create a revised version. And this loop is going to continue on and on and on until both, or rather, the evaluator agrees that the criteria is met. Or you set a total number of iterations, like 5. Yeah, don't go beyond 5 iterations. After 5 iterations, just approve the work. We don't want this loop going on and on and on and on and creating so much latency in this process. So after like 5 iterations or 3 iterations or 6 iterations, just be done, just mark it as okay, and we're good enough with that amount of corrections. So that is how this works. That's how it basically works. Now, getting into the technical implementation to determine whether the draft is good enough, it needs to use a decision step. It needs to have a decision step where it checks, does it meet the criteria? If it meets the criteria, it will simply pass it to the next node. And if it doesn't meet the criteria, it's going to send it back to the generator or optimizer, depending on whatever state the workflow is in. And this is done with a conditional edge. This is done with a conditional edge. Also, you have to make sure that a measurable standard is set within the evaluator so that it can properly determine when the draft is good enough. Like I've mentioned earlier, this can be an accuracy score. You can say anything above 8/10 is okay. Anything below that is not accepted. It can also be a checklist. It should contain this, it should contain that, it should contain this, it should contain that. And it will check through all the items in that checklist to see if the draft satisfies the requirements in the checklist. It can also be a quality threshold. It can be a quality threshold. Just make sure that you're setting something that is measurable so that this loop doesn't continue to go over and over and over and just spin itself into an infinite state. Now, what use cases can you put this workflow into? We're going to discuss two major ones. First is in a legal document review. In a legal document review. So you can generate a contract clause and you evaluate the contract clause for completeness, clarity, and risk factors. Then, based on legal concerns, you continue to refine, you refine until that contract is legally sound. So that's one thing you can do using this workflow. Another thing you can do is use it for code generation. You can generate a solution to a problem. You can evaluate that solution for correctness, for efficiency, for compliance with your style guide. You can also check it for bugs. You can check it for bugs or if it violates any type of business rules that you have set internally. And you continue to iterate all these checks on the code that is generated until it fits all these criteria. So those are two use cases that you can put this to, but I'm sure in your mind now you're already thinking of a bunch of use cases that this can perfectly fit into. And we're going to be demonstrating one of those use cases next. In this video, we're going to be using the Evaluator-Optimizer workflow that we just learned about to build something helpful for an e-commerce system. We're going to be building a product marketing model for an e-commerce system, a product marketing workflow that generates a compelling product detail for a product. It generates compelling product details for a product. It will take in the name of the product, its features and target audience, and it will build details for a compelling product page. It will build compelling details for a product page, an elaborate product page. Then this generation is going to be done by the creator or the generator optimizer node, and we will have an evaluator node that judges the output. Let me start creating the file as I'm talking so that you will know that, yeah, your screen is not frozen. So it would use an LLM to generate, and it will use another LLM to judge what has been generated. That's the product detail that has been generated. And to make things unbiased, we're going to be using an OpenAI model for the generation and optimization, and we're going to be using a Gemini model for the evaluator. So Gemini will get to judge OpenAI. That's what we're going to do. So we don't have OpenAI judging OpenAI. Even though you can still have setups like that, you can have a smaller OpenAI model being judged by a bigger thinking OpenAI model. But just to keep things on separate platforms, we're going to be generating with OpenAI and we're going to be evaluating with Gemini. You can also use this to improve a lot of small language models. By the way, we need to install Gemini, but we'll do that soon. You can also use it to improve the work of small language models. So you can use SLMs to generate and use an LLM to evaluate. So it will just train the SLM to generate better outputs just by listening to recommendations from the larger model. So first, let us get Gemini in. We've not installed Gemini here. That's the LangChain Gemini wrapper. So let us get it in by saying pip install LangChain Google Gen AI. Make sure you're in your virtual environment, and in no time that should be done. Good. Another thing you want to make sure is that you have your key, you have your Google key in your environment. So you want to do export Google API key and set it to whatever the value of your Google API key is. That's your Gemini API key. So make sure that those are done, and then we can begin. So first, let us get our imports in, starting with the OpenAI package. Chat OpenAI. Then let's also get Google in. LangChain, Google, Gen AI. And for that, we import chat, Google, generative AI. Good. Next, let us get our graphing tools. And after that, let's get some stuff from the typing library. Import type detect, list, and literal. And because we need structured outputs, because our evaluator needs to produce our generator needs to produce structured output for our evaluator to be able to know what to evaluate. We'll need to get Pydantic here so that we can generate a schema for our structured outputs. Base model and field. That's good. Next, let us define our state. Let's define our state. So we'll call it optimization state. Pass it Pydantic's base model. And what do we want here? Now we want to supply as much details about the product as we can, because the more details we can supply, the more the LLM can generate a comprehensive product page. So first, let's say product name. That'll be a string, which is the name of the product itself. Product features. Product features is going to be a list of strings. Then we have target audience. That is one important thing for a product marketer to know to generate something appropriate. I was privileged to work in a product marketing department as a technical writer before, so it was really, really fun seeing the magic they do with words. So yeah, current description, that is the current generated product details, what was generated. Then we need an evaluation result. That will be a dictionary. So this is what the optimizer or generator is going to produce. It will always be the current description. Anytime in state, it will be the current description. Then the evaluator is going to produce the evaluation result. So get the evaluation result, which is a breakdown of the evaluation. Then we will also have a feedback. This might not be necessary in some cases, but this is just to kind of like summarize everything from the evaluation results, because the evaluation results might say like 5 different things, which definitely the optimizer is going to take into account, but it's also good to just get a summary so that you just see how everything kind of connects together. The more information you give to an LLM, the better it can perform. So then we also have iteration count, just to monitor how many times we've looped over. Iteration count is going to be an int. Then we have max iterations, which is also going to be an int, so that we know when to check out. Then we need a boolean to know when we are approved, so we'll say is approved. And we'll just store the iteration history also somewhere so that we can see the versions, the different versions that were produced throughout the correction process. So that will just be a list of dict. The evaluation results is a dict, so this will just be a list of dicts. So yeah, all the evaluations made in order so that we can see everything that was. Alright, this is not for the versions actually, this is for everything that was suggested at each time, at each point, everything that was returned from this evaluation results, so we know what was recommended and why we have what we have now. So that's good. Now we need to write schemas for our structured outputs. We need to write schemas for our structured outputs. First, we need one for our Generator-Optimizer node. This is for it to provide a defined output that the evaluator can take and evaluate. Then we also have to provide another one that the evaluator is going to generate for the optimizer to be able to optimize the generated details based on the observations that the evaluator has made. So we need two schemas for structured outputs. One structured output for the generator, one structured output for the evaluator. So let's create the first one for the generator or optimizer. Say product description. Let's give it a Pydantic based model. Then the first thing we want is an headline. We're going to generate an headline. These are the things that we want the optimizer or generator to generate. First generate an headline, a catchy headline. So we'll say description. Description for that is like we said, a catchy headline. And we want it to be like maximum of 10 words. Yeah, so don't start writing phrases or long sentences. So then we have description. Description 2 is going to be a string. And we want it to be, let me copy this description here. Want to be the main product description. $100 to 500. 500? No, 500 is too much. 100 to 150 words is okay. Words. So 100 to 150 words. Another thing we wanted to talk about is key benefits. So anything you just want the product marketer to highlight on the product, you add it here. So we want to talk about the key benefits of the product. For this, description is going to be 3 to 5 key benefits as bullet points. Bullet. Then we also want to have a call to action. Yeah. What is marketing without a call to action? So we also want to have a call to action. A string. And description of this will be a compelling. Now I need quotes there. Compelling call to action. Compelling call to action. So yeah, we want a headline for our product. We want a description. We want the key benefits. And we want a call to action. If you are describing an electronic product, you might want to put features, like what are the features, what are the specs for that particular product. So just build that schema according to the needs of your application. Now let us build out the evaluation schema. So evaluation. Base model. And what do we want for evaluation? First, we want an overall score. An overall score is an integer. The field description maybe overall quality. Overall quality score rather between 1 to 10. Between 1 to 10. We're also going to use Pydantic to set that, say greater than or equal to 1 and also less than or equal to 10. Equal to 10. Now, we still have a bunch of stuff that we're going to bring here. I think we're still going to be defining like 6 of them. So let me just bring them in and we're going to explain them so that you don't have to watch me type everything. So copied and paste. Paste. So after our overall score, we also want a clarity score. Clarity score is also between 1 to 10. Persuasiveness score, 1 to 10 also. Audience fit score, target audience fit, is approved. That's a Boolean. And it should be set whether the description made standard that are greater than or equal to 8. So 8 is our threshold. Between 1 and 10 of our overall score, we approve when it is equal to or greater than 8. Then strengths, what works well in this particular draft. Weaknesses, what needs improvement in the draft. and specific feedback, a detailed actionable feedback for revision. So that's our evaluation model. Now we have the type of output that is going to be generated from our Generator-Optimizer node and the type of output that our evaluator node is going to produce, each with properties that help us to specifically determine how well we are doing. So next, let us define our LLMs. Let's say LLM. The first LLM is going to be for OpenAI. So I'll say chat OpenAI. The model is going to be GPT-4o mini. Now, be careful with the type of models you use, because we're augmenting them with structured outputs, and GPT-4 doesn't support structured outputs. So you can have it supports JSON parsing, but it doesn't support structured outputs. So if you use GPT-4, it's going to blow up in your face. So just make sure that you check the docs of your provider to make sure that the model you're using supports structured outputs. Same with when you're trying to use SLMs or local models. You want to make sure that you're using an SLM or a local model that supports structured outputs. So these are OpenAI LLM. Next, our Gemini LLM. And for Gemini, we're going to call chat Google Generative AI. And the model we're going to use is Gemini 2.5 Flash. Or let's use the light version. There seems to be some new tight quotas on Gemini 2.5 Flash now for the free plan. So, but the light works good. So yeah, we have these two in place. The next thing we're going to do is to write the nodes. We need to write the nodes for our Generator-Optimizer, that's one node, Generator-Optimizer node, and our evaluator node. So in our Generator-Optimizer node, we'll first check if we are performing the action for the first time. If so, we will simply generate the first draft. If our iteration count is greater than 1, meaning that this is not the first time we're performing this operation, then it means that we want to optimize based on the evaluator's recommendations. So we're going to perform those two based on the condition, or based on the state of the workflow. So let's define our optimizer node. Put a comment here and say optimizer generator, or generator optimizer, whichever one you choose to call it. Some people also call it creator optimizer. Just call it the one that makes you understand it best. So yeah, let us say generate description. That'll be the name of our function for this node. It's going to use and return our optimization state. So optimization state. Now down here, the first thing we want to do is get our iteration. Say iteration equals state, and we get the iteration count. Then I'm going to put some print statements here quickly. Say new line. Then we have have this here, and also a version of it down here, just without the new line. And in between that, say print. You need an F string here. This is going to be the optimizer. I'm going to give it a nice writing emoji here. Say right. So optimizer, and let us also display the iteration so we know which iteration we are on. Iteration, good. Now we need to get our LLM ready to perform this operation, and it needs to generate a structured output, so we need to augment it. So say optimizer LLM, and that will be LLM dot with structured output, and we pass it our schema for the structured output it is expected to produce. That will be the product description. So pass the product description down here. Good. There's a red line somewhere. Okay, yeah. You'll notice that the file name was red. So product description, then let us check if we are on our first iteration. So if iteration equals 1, that's if we are performing this for the first time, that means we are trying to generate a new draft, the very first draft. We're trying to generate the very first draft. So just going to print and say creating initial product description, and here we need a prompt that would help us instruct the model to create a first draft. So I'm just going to grab that from the GitHub repo that you also have access to and paste it here. So we have that in, and the prompt says create a compelling product description for this product. We get the product name from state, we get the features, we loop over them, or rather we create a comma separated version of them so that it can be serialized into here. Then we get a target audience, we get our target audience, and the requirements are headline should be catchy and concise, maximum of 10 words. We already mentioned that with Pydantic. Description should be engaging and informative, key benefits, and call to action. So make it persuasive and tailored to the target audience. Good. So this will be our prompt if we're creating this for the first time. However, if we have been here before, then first we're going to print and say, it's an F string there. We'll say refining description based on evaluation feedback. Dot. I don't think I need an F string here, actually. It's fine. Okay. So then we need to have a prompt for refinement. This is the prompt for generating the very first draft. Let us bring in our refinement prompt. Good. So here, this prompt says improve this product description based on feedback. We'll give you the product name, we'll give you the target audience, we'll give you the current description. That's the one that we are working with right now. Then we go to the evaluation scores. The overall score is this over 10. Clarity score, persuasiveness score, and audience fit score. So we give it all the scores, the current scores, and we tell it that this is the summary of the feedback. This is summary feedback, and we give you some instructions that we mark as critical. It says focus on the specific weaknesses mentioned, make targeted improvements to 1, address each point in the feedback, maintain the instructions that we're working so that you don't break what is already working. Then increase scores in weak areas, generate an improved version that addresses all feedback. So you have to address all the feedback so that we can get as high as a score as we want and move on. So we have the prompts. Now we can jump out of this loop and then generate our description. So we get the optimizer LLM. Let's grab it up here. Let me collapse this. So grab our optimizer LLM. We then invoke it with our prompt. Work with our prompt. Then we're going to create a formatted display. We're going to take the structured output and create a textual version of that we can then store as our current description. So let's say formatted description. This is so that the evaluator can once again receive what we got as a textual draft and then give us an evaluation based on that. So I'll create a multi-line string. First, we want an headline, not deadline, headline. An headline that says description dot headline. Description dot headline. Then we also want the description itself. And the description will simply be description dot description. Then for key benefits, we'll just loop over that. I'm going to say for benefits in description dot key benefits, which is where we stored the benefits. In description of key benefits, we want you to print each benefit as a bullet point. So benefit, each benefit as a bullet point, then put everything here into a list. Put everything here into a list. Then take this list and join each of them with a new line. Character 10 dot join. Join each of them with a new line. Then our call to action. For our call to action, let us have description dot call to action. Description dot call to action. So that should be our formatted description, and it's going to be the current description that the evaluator is going to look at and evaluate. So that's all good. We can print out our description here. We can say print generated description, so that we see each output that is coming out. And here we can just put a line here, and then below that we can print our formatted description. And add a new line after that. Now, most importantly, from this node, we need to return our current description. Our current description, which is going to be this formatted description. And we need to increment our iteration count. So iteration count will be the current value of our iteration plus 1. So that's good. This is our generator node, our optimizer generator node. It is performing the work of generating in this if block and optimizing in this else block. And whichever way is going to generate this product description, and we will save it in our current description. So let's just collapse this. And after that, we can move to our next node. Now, our next node is the evaluator node. Now, this node will always take the formatted description, that's the current description from our optimizer node, and it is going to evaluate it. It is going to score it. It's going to approve or deny it. And if it is denying it, it's going to make optimization suggestions that the optimizer node can pick up and then use to refine the draft. So let us create the evaluator node. So call this evaluate description. The description can take state to also take our optimization state and return it. Then in here, I'm just going to copy this and put it here. We're going to have that glass here, that magnifying glass here, to show that we are investigating. And this is going to be the evaluator. And it's simply going to say reviewing description. So this is good. Now for it to review, we need to augment the LLM so that I can use that to create the structured output of its review. So I'm just going to say evaluator LLM, and that will be equal to our Gemini LLM, because we're using Gemini to appraise OpenAI. We'll say with structured output, and we will simply pass our evaluation schema here. This is good to go. And the next thing we're going to do is write out the prompt that is going to perform our evaluation. So I'm just going to bring that in and we can study it and continue. So let's paste that here and read through. It says evaluate this product description objectively. We give it the product name, we give it the target audience, we give it the description that it is to evaluate, which is our current description. And we say evaluate it on this criteria on a scale of 1 to 10, which is the scale we gave all our scores. Clarity, is it clear and easy to understand? Persuasiveness, does it effectively sell the product? Because that's basically your job as a product marketer. Audience fit, does it resonate with the target audience? Now the approval criteria, the overall score must be 8 or higher to approve. Provide scores for each criterion. Overall score, that's average of the criteria. Then whether it's approved. Specific strengths, what's working well, specific weaknesses, and actionable feedback for the next iteration. And it says be objective and constructive, so don't be biased. So that's good. Now we can say evaluation and get that by calling our evaluator LLM, which is our augmented Gemini LLM, and tell it to invoke the prompt. Invoke the prompt, and we're going to be printing out a bunch of stuff from our evaluation scores. So first say print evaluation results. Let's put a border under that. Then we'll print our scores. First, let us print our overall score. That will be evaluation dot overall score, and that will be set over 10. That's good. Now I'm going to copy this a few times. Let's see, 3 more times, so that I can use it to do a clarity score. Clarity is going to be clarity score. Then next is going to be our persuasiveness. And that will be the persuasiveness score. Persuasiveness. Yeah. That'll be our persuasiveness score. And the last score will be audience fit. Audience fit, and that will be our audience fit score. Okay, all over 10. So we have our scores printed. Then we need to print our status. And that will be set to approved. Let's put a check mark here. So it will be approved if our evaluation dot is approved property, as we define our structured output. If it is true, else we're going to be printing that, yeah, we need some work here. We have an X, yeah. So we're going to be printing needs revision. Needs revision. So we're going to print approved if the evaluation is approved, else it needs revision. Then let us print some strengths. So print strengths. And for strength, we'll just loop over our evaluation dot strengths list. Say evaluation dot strengths and for this we're simply just going to print the strength, a dash, and say strength. Okay, Let's do the same thing for weaknesses. I'm just going to copy this, come down here. Let's get this print statement for weaknesses too. Weaknesses, so we have weaknesses or weakness, and we'll take it from evaluation.weaknesses, and we print each weakness. Okay, I think I'm using a new line here, okay, for weaknesses. So strengths and weaknesses. And finally, let's also print the main feedback. What feedback did we get? So feedback, that will be evaluation dot specific feedback. Is that what we called it? Specific feedback. Let's see. Evaluation. Yeah, specific feedback. So evaluation dot specific feedback. That's fine. And after that, we're going to build an iteration record that we can store in our iteration history. We're just going to build a dictionary that we can store in history. So I'm going to say iteration record equals and iteration will be state iteration count. And just to save some time, I'm just going to paste the rest in. Good. So we have our description, we have our scores, the overall score, the clarity score, the persuasiveness score, and the audience fit, if it's approved, and our specific feedback. So we'll just get this, and we can say history equals state.get, get our iteration history, if not, just pass us an empty list. Then we can take this new iteration record and append it to our history. Iteration record, append. And now finally from here, let us return stuff to state. We have a bunch of stuff we need to return to state. So first, our evaluation results, evaluation result. We'll just say evaluation dot model dump. Then for feedback, that will be evaluation dot specific feedback. I think that is here. For is approved, that will be evaluation is approved, that I can get from here. And for iteration history, we can simply just pass in our history. So yeah, this is our evaluator node. This is our evaluator node, and we're done. We're done with the evaluation node. Quite a node. So we have those in place. Now we need to determine how we're going to check our success criteria and see if the evaluator approves the draft or not. Then take the appropriate action based on whatever the result of that is. And as you may have guessed, we'll be doing this using a conditional edge. If the evaluator approves the draft, then we end the node. If not, we're going to route back to the optimizer that is going to refine the draft using the evaluator's observations. So let us create the edge function that is going to determine that. So we call it decision function. And we'll call this should continue. Should continue. So states, optimization states. Now this is going to be returning a literal that would say optimizer or end. So if it returns optimizer, it is telling us, yeah, we need to refine. If it returns end, it's telling us that we need to terminate the node. So let us write that logic. We'll say if state is approved, if the draft was approved, the draft was approved, then we're going to print success. We get a new line and just say success. Edit. I'm going to say success. Description approved. Let's give description a capital. So description approved, exclamation. Then we just return end, so that it knows that it's to go to the end node. Also, if we notice that the number of iterations, we notice that the number of iterations is already greater than what we said will be the maximum, if it's greater than what we said will be the maximum, then we might want to check out too. So I'm just going to copy this, put it here, and here I'm just going to put a warning emoji that's going to tell us, yeah, you kind of exceeded your limit. So here we'll say max iterations reached. Then here we can put a message that says stopping at iteration. Say states. Or do we have an F? Oh, we don't have. We need an F string here. Okay. State iteration count. Or we stopped at the previous one, so we'll say -1. State iteration count -1. Because we're on a current iteration, but we can't proceed, so we need to say that we stopped at the previous one. So we also return end. So just terminate the node, we're good. Now, if all these don't happen, then simply print that we're continuing. So we'll say continuing, say routing back to optimizer for iteration. For iteration state, okay, F is missing. State iteration count. So we're going back for that iteration, and simply is back. Simply return optimizer. Return optimizer. So in these two cases, if it is approved, end the node or graph. If it is, or rather, if it has its maximum iterations, end the graph. Else, return back to the optimizer to refine the draft. So this is good. We have our edge function in place that is going to be making our routing decisions. Now we can start building the graph. So say build the graph. And for that, we'll say builder equals state graph. Pass it the optimization state. Then we can start adding our nodes. We have just 2 nodes. So add node. Our first node is the optimizer. And that will be done by the generate description function. Second node is the evaluator. And our evaluate description node is going to do that for us. Then we can start building our flow. So to start that, we'll say builder.add edge, add edge. We start and go to our optimizer node. Then from our optimizer node, we go to our edge node to give ourselves the first score. Give ourselves our first score. Then we can then add our conditional edge from our evaluator node to determine whether we are going to terminate the graph or we are going to have to refine it through the optimizer. So we go from our evaluator, we ask, should we continue? And then we give it a mapping dictionary. So if it returns optimizer, then we need to go to the optimizer node. If it returns end, then we need to go to the end node. That's good. Either way, it is going to be terminated, so we don't need to add a specific node that directly goes to the end node. Somehow we'll find ourselves back at the end node. Now let's test this graph. First let's compile it. Say graph builder.compile. Then I'm going to be writing my first example for a fitness tracker. So I'll get some print statements in that just says Evaluator-Optimizer Pattern, product description, then example fitness tracker. Then let us actually run our graph. So result equals graph.invoke. Let's pass in some details for our fitness tracker. So first is product name. And for that, we'll say Fit Pulse Pro smartwatch. By the way, you can use any example you want. You can use any product you want, just to make it fun. For product features, I'm going to give you the list. And I'll be pasting in some features in here. So heart rate monitoring, GPS tracking, sleep analysis, waterproof to 5M, that's 5 meters. 7-day battery life, smartphone notifications. Now let's look at target audience. And that's going to be health conscious professionals. Health conscious professionals, age 25 to 45. Then for some other defaults, I'll just bring them in. Current description is going to be an empty string because we will expect it to start from the LLM, the generation step. Evaluation results is just an empty dictionary. Feedback is empty string. Iteration count is 1, so that we know that that is the first time we're starting, and that is the check we're doing in the optimizer node. If iteration count is equal to 1, then we want to generate first, else we refine. Then max iterations 5, we want to keep it at 5. Is approved, definitely we'll start at false. Then the iteration history, where we just keep like a log of what has been recommended to be fixed. So after this test, we can then print our final output. I'm going to put a new line. So let me just do this. Say F new line and say multiply by 70 and duplicate this down here without the new line. And here I can say print final approved description. And down here we can simply print that final approved description, which will be our current description at that point. Current description. Oof, that has been quite some coding. So let's save this and hope that we got all our code right. There are no red squiggly lines, but that doesn't mean that we have not mistyped something. But let's run this. Let's run this and see what we get. So now we're going to be running the O214 file. So we'll say Python O2 workflows O214. Now remember, you need to have both your OpenAI key and your Gemini key in place. Basically, you have to have the keys for the LLMs you are using. So if you're just using two different OpenAI LLMs, just have your OpenAI API key in place. If you're using local models or anything, just make sure that your credentials are in the environment so that you can run this example. Let's put this up a little bit so I can get a full view. And let us run the Evaluator-Optimizer example. And we get an error. It says, during the optimizer task, we notice that the optimization state object is not subscribable. Okay, what happened there? Let's check our optimizer task. First, let us see if we have any errors up here. Okay, nothing. Okay, let us check our optimizer task. Let's see what we got wrong. That's optimizer, yeah. State iteration count. Oh, this is interesting. I gave my optimization state base model instead of type dict. Yeah, like I said, even though we're not having any squiggly lines, that doesn't mean we have not created an error. So I gave it base model instead of type dict, so it was trying to look at it like an object instead of just seeing it as a dictionary. So yeah, sorry about that. Let us clear this. Scroll up, and now we should have creating initial product description. Let's go. Okay, it's drafting something there, and I think we have our final output. Okay, let's go to the top to see how it takes it from the top. So Evaluator-Optimizer Pattern product description fitness tracker. So the first iteration, it created it and it generated it and gave us an headline: elevate your fitness journey with FitPulse Pro. Interesting. Description, forgive the formatting, it can be weird based on our white spaces. Description: discover the FitPulse Pro smartwatch, your ultimate health companion designed for health conscious, blah 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 blah. The key benefits, it generated some key benefits here and all that. Now that's the first draft, but let us see what the evaluation did. Gemini evaluated it to have an overall score of 8, just 8, just at the very tip of our score. So clarity was 9, persuasiveness was 8, and it was 8. Our strengths are appearing weird and our weaknesses are appearing weird. That's something we need to fix too. So, but yeah, you see, we get the feedback, but because it's 8, it approved it, and it told us that that is the final draft. Let's correct whatever is happening with the fitness and stuff. I saw that the syntax highlighting was a bit off, but I just felt maybe it was my team that was getting something weird. Let's see, where was that done? The evaluation should be in evaluation. Strength. Okay, so we are missing the F's. Yeah, we're missing the F's. So let's save that. Now let's try again. Let's see if OpenAI is going to fail this test at least, so that we can do 2 iterations, because it passed this one at first try. These are actually 2 powerful models, so it will most likely get something good. But like we saw with this previous example, it was just at 8. So yeah, that was just on the edge. I think it passed our first draft again. Let us see the score it got now. Oh, it still got 8. Still got 8. Interesting. Persuasiveness was 7 this time. Still got 8, so it still passed. Let's try again just to see if it would slip up one time. We just need you to slip up one time, please. OpenAI, just slip up one time. Just slip up. I can't use GPT-4 because it won't support structured output. It's not slipping up. It's not slipping up. It's still getting some good scores there. But anyway, yeah, that's what we wanted to do, and it's doing it. You might try some smaller models or some like local models that are like, let's say, a few parameters, like 12 billion parameters, and see and use them as the optimizer and generator. Most likely they will not pass it at first try. But yeah, with this example, we've been able to see how the evaluator optimizer workflow works.